Welcome to our CathCAD software training series of videos. This video will provide information on the deflection model that is incorporated into the CathCAD software. CathCAD Standard and CathCAD Advanced both support the capability of computing elongation and angular rotation when subjected to a force or moment. Multi-segmented designs are supported. The current released version of Standard supports 5 segments. The current released version of Advanced supports 7 segments. The resulting catheter design may be placed under a longitudinal force and/or moment about the longitudinal axis of composite tube. The computed output values are valid in the linear, elastic range of the design only. The force deflection model requires the introduction of the catheter length into CathCAD software. We now provide the basic process flow of the deflection algorithm used by the CathCAD software. This process is illustrated by the flow diagram provided on this page. First, the user enters and computes the design for a given segment design in the CathCAD software. Second, the user latches the design from step 1. When one or more segments are designed and latched, the user may analyze the design by applying a force or moment to the overall design in the CathCAD deflection module. Hooke's law is an empirical law which states that the force, F, needed to extend or compress a spring by some distance, x, scales linearly with respect to that distance. That is, F equals sign Kx, where K is a constant factor characteristic of the spring, its stiffness, and x is small compared to the total possible deformation of the spring. Hooke's law is directly applied in the force and torsional deflection models implemented in the CathCAD software. The CathCAD software applies Hooke's law when analyzing the case where a force is applied to the longitudinal axis of a catheter. The governing equation for this situation is provided on the screen where the following variables are defined. K is a spring constant. E is defined as the modulus of elasticity. A is the cross-sectional area of the catheter. L is the catheter length of the catheter. In this instance, the catheter length is not normalized or set to the value of 1. Optimizing the catheter segment length is a critical element that the designer must determine and optimize. The deflection of the catheter segment, when subjected to a force application, directly correlates to the resulting deflection. The Institute user will note the product of modulus of elasticity, E, times the effective cross-sectional area, A, is used in this equation. The product E times A is identified as the longitudinal rigidity, which is one of the CathCAD software's direct outputs. CathCAD software utilizes the principles of Hooke's law when applying a moment or torque about the longitudinal axis of the catheter design. The application of a moment to a catheter results in an angular twist or rotation, theta, about the longitudinal axis. The governing equation for this relationship is shown on the screen. The Institute user will note the product, shear modulus, G, times the polar moment of inertia, J, is used in this equation. The product of G times J is identified as the torsional rigidity, which is one of the CathCAD software's direct outputs. The deflection model in CathCAD is capable of handling multiple segments in series. The connected segments are modeled as a set of springs connected in series. In general, when 2 or more springs are in series, when any external force applied to the ensemble gets applied to each spring without change of magnitude, and the amount strain, deformation, of the ensemble is the sum of the strains of the individual springs. While this may seem complicated to the user, the good news is that the CathCAD software handles all of these calculations automatically. We now provide a multi-segment catheter design illustration. The figure provided on page 8 of this training session illustrates a 5-segment design. Each of these designs may be identified with a unique inner diameter, outside diameter, longitudinal rigidity, torsional rigidity, and length. In many actual designs, each of these segments are typically a different color, so they may be easily identified externally by the end user and also for branding purposes. This page summarizes the inputs to the CathCAD deflection model based on the knowledge learned from the prior page. Each of segment designs may be identified with a unique inner diameter, outside diameter, longitudinal rigidity, torsional rigidity, and length. The software is not responsible for making sure the various segments fit together. For example, a major mismatch in inner diameter and outer diameter values. The software assumes that the segment designs entered by the user are manufacturable and that the segments may be assembled together in a reasonable fashion. The outputs from the applied force module is the total or overall elongation. It also provides the strain and elongation of each individual segment. The relationships of these variables are provided on the figure supplied on this training page. The outputs from the applied torque module is the total angular twist or rotation. It also provides the shear strain and angular twist of each segment. The relationships of these variables are provided on the figure supplied on this training page. This training page supplies detailed instruction on how the user may latch and unlatch segments from the main CathCAD design page. The latch segments are used in the CathCAD deflection modules. The composite tube design parameters may be latched on the main CathCAD design pages directly after computing the output parameters within the software via the Compute button. A segment has not been loaded if it has a red background. A segment has been loaded if it has a green background. Segments may be latched loaded in any order. The user may simply click on the segment number to latch a design. At the program start, the user may clear a segment latched value, green, by clicking on it. The CathCAD software stores the latch designs locally on the user's hard drive space. These latch designs are available for future run instances. They are not removed until the user unlatches them. This training page illustrates the following screenshots. First, we provide a screenshot of the instance where no segments are latched. All segment assignments are shown as red in color. Next, we provide a screenshot of the instance where all the segments latched. All segment assignments are shown as green in color. Finally, we provide an example of the pop-up dialog that is shown to the user when a segment is actually latched. This pop-up dialog is the software's confirmation that the user has successfully latched the design. The pop-up window provides the computed value of the parameters that were latched as well as the design description in the CathCAD design layered format. Once the applicable designs are latched into the applicable segments, the analysis tools become available to the user from the main menu. The Applied Force menu item allows the user to apply a force to a latched design. The Applied Moment menu item allows the user to apply a moment to a latched design. This training page illustrates the Applied Force user interface. The user is allowed to change and modify the following fields on this page. The Applied Force entry field. The Enable checkbox. This checkbox allows you to include or remove a segment from the analysis. The segment length of each module. All other fields are red only. The module will identify when a segment is plastically deformed when a force is applied. The segment strain will be shown in RED when the software considers the segment to be plastically deformed. When the design is plastically deformed, the computed output values may depart from the actual measured values. This training PG illustrates the Applied Moment user interface. The user is allowed to change and modify the following fields on this page. The Applied Torque entry field. The Enable checkbox. This checkbox allows you to include or remove a segment from the analysis. The segment length of each module. All other fields are red only. The module will identify when a segment is plastically deformed when the applied torque is applied. When plastically deformed, the segment strain will be shown in red. When the design is plastically deformed, the computed output values may depart from the actual measured values. Once the multi-segmented catheter model is loaded into the module, the user may adjust the magnitude of the force or torque applied, as well as the individual segment lengths. CathCAD registered trademark deflection module will automatically recompute the applicable outputs. This allows the user to optimize the design, specifically the segment lengths. This completes this CathCAD training video. We invite the user to view and learn from our other training videos that are available on YouTube. For more information about the CathCAD software, please visit our website at www.cathcad.com